Hello, and welcome to the first video in the geometry section of our course. Today we're going to talk about geometry basics, which can be found in section 10.1 of your textbook. Here we have the rectangular coordinate plane. This is where we're going to start in our basics. Now you've probably seen the rectangular coordinate plane before. The plane is created by using two number lines, known as axes, where we have x and y. If we look here, along the axes, we have the x-axis and we have the y-axis. Location is on the plane given by the horizontal and vertical movement. So if I ever want to find a location, I have to move along the x-axis first and then the y-axis. We always start at the origin, which is considered the ordered pair 0, 0. This means we have no horizontal movement and no vertical movement, and it is essentially here. Horizontal movement is always first. That's why it's an ordered pair, because the first number is always horizontal and the second number is always the vertical. So if I want to find a location, let's say we go 6 over on the right and we go 7 up, we could then find a location on the graph. So on the rectangular coordinate system, it always gives us a location. A location is found by looking at the ordered pair. Remember that the ordered pair is always going to be xy. What that means is that x is going to be our first movement. In other words, the first coordinate of an ordered pair tells us how far we move right or left. We move right if it's positive, left if it's negative. While the second number is going to be the vertical movement. Again, if it is negative, we move down. If it's positive, we move up. So here we can see in this ordered pairs 4, 3. 4, 3 represents we went to the right 4 because it's positive, and we went up 3 because 3 is positive. While the other ones are negative 5, 4, negative 3, 2, and finally to negative 4. Please note that in the rectangular coordinate system, x and y are real numbers. This could be integers, whole numbers, fractions, decimals, even square root values, such as the square root of 2. So let's practice and graph. Let's suppose we want to plot the ordered pair 2, negative 3, and we'll label it A. One pick blue. Starting from the origin, we are going to move 2 to the right because it's 2 is positive, and remember the first is x. Then we're going to go down 3. 1, 2, 3. We will then plot right there. Oh dear, sorry. I haven't used this problem in a while. Click. Click right there. Ah, no. I just want to make a dot right there. Okay, there we go. So we'll call this A. And then finally, we will now plot the ordered pair negative 5, 3, and we'll label it B. This time we're going to go to the left, 1, 2, 3, 4, 5, and then we'll go up 3, 1, 2, 3. So right there. I wish it was a little bit bigger. No. Sorry. And then that's B, right there. Okay. Now the next 3 questions are actually the same thing. What are the coordinates of C? We give the ordered pair for C, and where is C located? These are all the same question. To figure that out, we look at how far we had moved right and how far we moved up. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5. We would write that this is 7, 5. This is the ordered pair where C is located. So now we're going to talk about the basic structures of geometry. The basic of the basics is going to be the point. A point is simply a single location in space. For example, the ordered pairs we just talked about is considered a point. Every structure from geometry can go back to a point. In this diagram, we have the points H, D, G, and F. These are all on the same plane of existence, while I, J, and K are also points, but they're not on the plane. From a point, we can create lines. A line is defined by any 2 points on the line and extends infinity in both directions. So essentially, a line is just has 2 points in it and it extends. Now 2 points is minimum, but it can have a bunch of different points. If we think about linear functions, all those solutions, all those ordered pairs that lie on the line would be considered a point of that line. Please note that lines continue on forever. We'll talk about other structures where direction either ends or only goes one direction. A line can be described by 1, by 2, or 3 points. We could also describe a line as a letter, which we'll see later. Points on the same line, they're called collinear. So we could say that the points D, G, and F are collinear. Now, when we do a line, we use the notation as follows. Notice how we have a little double arrow at the top. Remember that biconditional statement? Well, we actually use that to show a line in geometry. So the symbol is reused, but it means something different in geometry than it did in logic. So if we had called, for example, says if a line is labeled with a letter, we can also call that. So let's suppose instead of this line being J, G, I, if I had called it M, for example, I could refer to that as line M instead of just line G, I. So now let's talk about 1/2 of a line. Essentially, a ray is defined by 2 points on a line. The first point is always where the ray originates or starts, and then the other point shows you where the direction of that line of the ray goes. So a ray continues in one direction, unlike a line. So if we were to look at ray GF, now what is that ray? That is this ray right here. G starts and it goes here. We could also say in other rays, we could have ray GD with one arrow to the side. We could have ray GI, but I also could have IG. Now please note that even though we have the same letters, the ray GF and ray FG, they are the same letters, but they are not the same. This is different from a line. If I was describing the line FG and GH, it would be the same. But because ray depends on an endpoint and direction, the ray of GF is different from the ray of FG. Now we could talk about opposite rays. If 2 rays combine together to give you a line, then the 2 rays are considered opposite because they're going they're from the same endpoint, but they go in opposite directions. Now let's make it even smaller. A line segment is simply a piece of a line, is the easiest way to say it. In your book it says it's defined as 2 endpoints showing that there are a definite beginning and a definite end. A line segment, because it is a distinct piece, it also has a definite length. The line segment is described at 2 endpoints, and we can use the line as follows. So we could say DG is one of the line segments, but we also could write the line segment GF, the line segment IG, among others. You should note that when it comes to a line, a ray, and a line segment, we're still using two letters to represent the structure. What is different is the symbol on top. The symbol on top distincts or defines what structure you're actually talking about. Now, just like a line, the line segment, if we use the two different letters for it, the two different endpoints, it is the same. So remember, a ray is not the same, but a line and a line segment, you can use the same two letters and it represents the same structure. Now let's go beyond that. Once you have points, you can create lines. If you have lines, you create planes. Planes, as defined by Euclid, is a surface which lies evenly with the straight lines on themselves. We can think of a table surface as being a plane. Here in the diagram, this rectangle, or this, let me go to here. This parallelogram is considered the plane. The plane extends forever in two directions. So if I had one line here and one line here, this plane would actually go on forever. All we're seeing is a piece of this plane. A plane can be described by two lines, which are on it, or by three non-collinear points. Non-collinear points are simply points that are not on the same line. Now, they have to be coplanar though. For example, point D, point F, and point H. Point F, all three of those are on the same plane, but not the same line. D, G, and F are all considered on the same line, but it would be difficult to describe that as simply a plane because it only shows one direction if you're on the same line. And if I had the two lines, so if I have two lines that are on a plane, we have it on, that are called coplanar. The two lines we have here, line DG and line IJ, are not considered coplanar. Actually, line IJ goes through the plane of P. So how could we define this plane? Notice here in the corner, we have the letter P. So we could just say this is plane P. We could also describe it by three coplanar points. So I could also say this is plane D, H, F. I could change the order of those of the points. I could also have picked G instead. As long as I had a combination of H, D, G, and F, I would have a plane. Remember, I have to include H because it is the non-collinear point, but it is still on the plane. What I want you to do now is I want you to pause the video and I want you to figure out, I want you to answer the questions that are here. So please take a moment to pause the video so you can practice your understanding on what was covered in this video. Now that you've practiced, let's look at the answers. Here are the answers to all the questions. Please note that some of these are not all the possible answers, but only a few. Remember that collinear means they have to be on the same line, so we could have done either A, B, C, or we could have done E, D, F. Although we do have a secondary line here on the plane, we only have 2 points, so we couldn't use that for the 3 points. Then we have the non-collinear points. As long as you found 3 order pairs that are not on the same line, but on the plane of P, you're good. 3 coplanar points. Pretty much the same idea as the previous answer. As long as it's some combination of 3 points that are not on the same line, but all on the same plane of P, we're good. We have 2 lines on the plane. We could either describe this as AB and BD, or AC and BD. However, we could have used a combination of any of these to have that answer. Plane P, we can give a bunch of different answers. P is the simplest, of course, but then we could also pick 3 coplanar points to describe this same structure. I want to repeat, it's the same structure, just given different names. If I want to name the line that's not on the plane, that is simply EFH. Now we can use 2 of those 3 letters, and remember to put the symbol of the double arrow on top to signify line. Finally, we have the rays. Again, as long as we pick 2 of any of these are considered a possible answer. Please note that when we talk about array, we are using the one direction arrow, which was the conditional for logic, but now we're using that as a signal for ray. Note that AB and BA are not the same, so we could use both of those as an answer. When we talk about opposite rays, we have to focus on the 2 lines that are on the plane because those are the only ones where we have, or I guess we could do the ones on the plane, or we could do the ones off the plane. So the one I didn't include, no, those are the only 2 options. Again, since I don't have another ordered pair for the line BD, I can't use that as my opposite rays. So I had to use line AC, or I had to use line HE. And again, line segments, as long as they're on the plane, which means it had to be either on line AB or line BD. There you have it. Next, when we go to class, we're going to be going over some practice problems with this, as well as a little more of a deep dive.